Alright, we're asked to write an augmented matrix of the system to use it to solve the system. And then if it has an infinite number of solutions, express it with a parameter z. So we'll worry about that depending on what our answer is, whether we have to write it in terms of a parameter z. So here we have our matrix. So first thing I need to do is rewrite it as an augmented matrix, which we're going to do. So let me get my pen here. So remember, my augmented matrix is just the coefficients of the equation. So I have 1x, negative 3y, 3z, and then the constant is 10. And then I have 1, negative 2, 2, 5. Then we have 2, negative 5, 7, and 19. So that's all my coefficients and constants. Now remember, these were the x's, these are the y's, and this is the z's. And that's going to be helpful once we get our answer. So now, from here, I'm going to use my calculator. And I'm going to use the rref that we have. If it will let me. Hold on here. rref on my calculator. So let me bring up my TI-83. And we're going to put this augmented matrix into our calculator. So I'll go second, matrix. We will scroll over to edit, enter, putting it in at matrix A. This is a 3 by 4. 3 by 4. And we'll just enter our coefficients here into each spot. So, and it's important to make sure you put each one in correctly. So like I said, 2, enter, and just after each number you have to enter. And you see it automatically goes to the next row. So as we get all of these in, alright, okay. So again, we can double check to make sure we have our numbers correct, and it looks good. So I need to get out of this, second, quit, go back to matrix. This time I'm going to go to math, and this is where I look for the rref, and there it is, it's B. And you can scroll up or down with the little arrows, but I want the reduced row echelon form. Enter. Go back to matrix, and this was matrix A. Enter, and I always like to close my parenthesis. It's not necessary, but I like to do it. And there is our reduced row echelon form matrix. Okay, so what does this tell me? Okay, so it looks like I have 1, 0, 0, negative 5, 0, 1, 0, negative 3, 0, 0, 1, 2. Okay, so I'm going to write my new matrix over here. So this is after we reduced it. So it looks like I got, let's see here, 1, 0, 0, negative 5. And we had 0, 1, 0, negative 3. And then 0, 0, 1, 2. Now, remember, x, y, and z, as we did above in our augmented matrix. I can rewrite this as an equation. Okay, so that's 1x plus 0y plus 0z equals negative 5. 0x plus 1y plus 0z equals negative 3, and then 0x plus 0y plus 1z equals 2. So again, 0 times y, 0 that's 0. So it looks like x equals negative 5, y equals negative 3, and z equals 2. And so that's my solution. This actually has a particular solution, not infinite number of solutions, so that's our answer.